Good afternoon, everyone. My my work is the automatic detection of contextual laterality in mammography report using large language model. I am Eduardo Godoy. The works participate to Joaquín de Ferrari, Diego Mellado, Esther Chabert, and Rodrigo Salas. We are from University of Valparaíso, Chile. And the context of these works is a NLP applied to mammography reports. The objective of this work is to extract the context relate to laterality. The laterality is the breast right or left in a mammography report. Initially, the scope is limited to evaluate the best GPT models that can accomplish to the task. We are using a data set of 314 annotated of the 1,317 report. The comparison with other models is part of the second works in the next time. As introduction, in Chile, the breast cancer is the highest incidence in the woman. Early detection is essential using principle the mammography. The mammography is the first exams. The process is the patient goes to the box, then the device take the image sent to the medics or doctor, and the doctors analyze each image, and then for searching for anomalies, okay, and then write a report. The report is composed for four principal sections. We have the patient sections, the patient data section, the finding sections. The finding sections describe all of the medic what in each image. For example, anomalies, sectors, etc. Each findings or anomaly is composed for three principal concepts: the laterality, the breast right or left, the location refers for a quadrant of the breast, and the finding. This is the anomaly: a nodule, microcalcifications, maze, retraction, and each one. And the fifth section is the impressions. Impression is a little resume of the exams and description for all image, and then the doctor adds a recommendation for the patient. In the last sections, we have a VRAT. The VRAT is an estimation of the grade, the disease of the patient. About the problem is basically we have one report, we have many images, and one report describe two body parts, in this case two breasts, and then without order. Okay, so we can try to find the text referred to one breast or other in the report for describe the image correct. As a solution, we have many solutions in this case for this problem, but the principal problem in this is this take hard work, because we need to start with the labeling process, then train the model, and then evaluate the model, and then evaluate the results and validate with the clinics persons. And we propose use the LLM models capacity for simulate the spans the span categorization problems. In general, the span categorization problem is fixed to this task or problem in question. So we propose to changing the task, the labeling and training for others tasks with minor cost using LLM. This is a typical NER span categorizations where we have in the yellow line context laterality for, in this case, the press left, and then we have a overlaps for, in this case, the location, and other overlaps in this case for findings. So this is a typical problem. We need to extract this text and then link to the respective image. For methods, initial, we have a data set when we have a 4 or more image in two principal views, the CC and the MLO. Okay, so then add and report. That is a principal dataset. Divide in 377 the annotated, and then the rest of the report. Okay, we have tried to deal with only with the reports. The image don't play in this work. So this is a three principal stage. First, we test and observe and fix each error pattern, or only is a principal is a first evaluation for the initial process. Then we will execute annotated data for extract metrics, and then we execute all data for evaluate the final results. This is a typical process. We have the prompts. Sorry, we have the prompts. Then we have each report when we extract the finding section and the impression section and build a JSON document. So we take the prompt and the document and send to the LLM using a framework for conversing with the model. So the output is evaluated for us, and then in searching for a typical error pattern, and then classify the pattern in a heuristic solution or a reprocess solution. For what a heuristic solution? Because it's more cheap repair this in using a typical human task. If we could, in other case, we need to reprocess the output and then create a new prompt or evaluate if we enrich the first prompt. So the output of this model is the laterality label, and then the position for the initial and end of the sentence. This is a model, sorry, the framework in details. We can check in the paper if you want. So the three principal errors we can observe in this experiment initial, stage 1, is first the label position. The label position is when the position that's returned the LLM is not related to the initial the beginning of the sentence, okay, or the other case in the end of the sentence. So we first enrich the principal prompt for add the words initial, because we observe that the LLM is very good when return the words and for over the position. So we retrieve the words and the positions for this case. Then we apply a heuristic if the error persists in the second time. For the structures, the error of format structure is a typical error when the model, LLM model, cannot be built output where what the we indicate. Okay, so for this example, for this error, only we build a template and then we get the output, compare and validate if the error persists. We extract the values and build a new output in a manual solution. For prediction results is the most severe mistake because we cannot use a heuristic in this case. So in this case, we can build a prompt and reprocess the output join with the input. And then we say the model, here's the input, here's the output. This is a some error. Please repair or re-estimate the label in this case because this action is when the LLM cannot be predicts the label and the sentence. For the metrics, we evaluate the results using intersection over union for NLP problems. This is a metric commonly used in NLP task. This evaluates the overlap between the spans predicted and refers to the span the raw truth. Okay. For the formula is the first the length of the intersection. This is when the token is equality of the round truth is countable, and then the other value is the length of the sentence compared with the LLM sentence that's output. And for the evaluate, we can build using intersection of a junior, the TP, FP, and FN values. So with these values, we build a recall, precision, and F1 metrics. As a preliminary results, this is a typical input-output from the LLM. This is a real report. Then we send to the models. The models return the value, in this case, the position, the init words, and the endos position, the endos word. The LLM return the label, in this case, is press right, and we can find the text associated to the output. Okay. In this case, the reports have two references, first the right and then the left for anomalies. As a result, first we can check the three versions of the GPT, and 0 shot, 1 shot, and few shots. 0 shot is when we send the model the prompts and the input data. The 1 shots we add at the first some example, the input and output, and the few shot we add 2 or more examples to the request. Okay, so in this case, we can check that the 3.5 turbo in this case reproduce less error, the type 1. Is an incidence result because, for example, for O, reproduce 951 error. Maybe, or not maybe, is the 3.5 turbo only detects least sentence. So for what they reproduce minus less error. Okay, so in GPT-4 reproduce more error because is being able to estimate more labels and sentence. For the seconds, for example, for O is very good building the output, and in the error tree and the first attempts we get 30 errors, and then we try to repair this error, and GPT is very good and repair all errors. For example, in 3.5, it's now been able to repair all errors. This is for all dataset, and this is a metric for our dataset labeling, annotate. So, for example, the GPT-4o, we have a 0.77 F1 metric. We can see that the GPT 3.5 cannot be repaired the error tree in this graph. As a future works, we need to compare this result with other LLM like Llama or Gemini, and we are building a BERT for this case too. Other uses for this is we need to extract the sentence for label a model for generate reports about from the image, and we can use this for image reconstruction too. As a conclusion, evidence the GPT-4o show promising performance of the model in detecting laterality spans in mammography reports. And LLMs can leverage their ability to understand the process, natural language processing, to identify reference to left and right breasts in radiologic report. For example, O offers several advantages over the model training with annotates dataset in extracting import and information from mammography report. The principal evidence here is the LLM for O is able to estimate the span and compare with the ABERT model, for example. This is an acknowledgement for my university and government, and this is a presentation. Thank you very much.